All right, evaluating an inverse trig function composed together with an original trig function. But this time what's going on is we have like sine inverse and cosine combined together, or cosine inverse and sine. So it's not the same function and it's inverse. So how I like to work these is I like to evaluate the inner part when it's a regular cosine or sine on the inside. Evaluate this first and then work on taking the inverse of whatever ratio we result in. So what I like to do is, and this is not the only way to do this, we could do cofunction identities, we could rewrite sine and cosine in terms of sine, or other ways. But I would focus on cosine of 13 pi over 6 on this first one and see if I can evaluate what's on the inside here. So the first thing I'm going to do is go ahead and think about what's a coterminal angle to this. This angle is just a little bit too big, 13 pi over 6. That's not the first time around the circle. That's bigger than 2 pi. So let's do just a little bit of side work here and find a coterminal angle. All right, so I'm looking at 13 pi over 6 and saying, too big. Let's subtract away 2 pi. But I'm going to strategically rewrite this. So it's going to be 12 pi over 6. Which is equivalent to 2 pi, just to get a coterminal angle that fits in the first time around. So 13 pi minus 12 pi's leaves us with pi over 6. So we can rewrite this as sine inverse of cosine of pi over 6 on the inside here. And this may be a good time to pull out our cofunction identities if you choose to go it that way and rewrite what's on the inside in terms of sine. Instead, what I'm going to do is I know I can evaluate cosine of pi over 6 pretty easily. That pi over 6 is a nice angle. We can say that's the same thing as sine inverse, just bringing that along from the outside. And then evaluating cosine of pi over 6 is going to be the square root of 3 over 2. So I'm simply replacing what's on the inside here. All right, so at this point, we're just trying to evaluate sine inverse of the square root of 3 over 2. I may go ahead and just set this equal to a dummy variable. I'm choosing x. And we can rewrite this in terms of sine, that we know that we're trying to find the square root of 3 over 2 is equal to the sine of x. We're trying to think what angle, when I plug it into sine, would produce this ratio square root of 3 over 2. So hopefully we've got down that this is a nice ratio that shows up a whole lot. We can say that if I plugged in the angle pi over 3, or 60 degrees, this is just written in radians, in for x, then what's going to happen is that would produce this desired ratio. So our solution in this case is going to be pi over 3. Let's do another one pretty similarly here with cosine inverse on the outside, composed with sine of negative 11 pi over 4. So again, this is a good candidate for, I don't like that negative angle on the inside here. So let's find a coterminal angle. And you won't have to do this on everyone, but in our case, I think finding a coterminal angle to negative 11 pi over 4 is going to be handy. So I'm going to add 2 pi. I'm going to strategically write it as 8 pi over 4. 8 divided by 4 is equivalent to that 2. So this brings us to negative 3 pi over 4. Now, still not in the first time around the circle. So I'm going to do this one more time and find another coterminal angle. Let's go ahead and add another 2 pi, or 8 pi over 4, which will bring us to 5 pi over 4. All right, so we can definitely rewrite this as cosine inverse of sine of 5 pi over 4. And remember, as long as you're finding a coterminal angle, you don't have to really worry about positive or negative. It's going to be equal to the original, just rewritten with an equivalent angle that's just coterminal. All right, now evaluating sine of 5 pi over 4 can be a little bit difficult. This is where I'm going to be thinking about a reference angle. All right, so a reference angle, I'm going to go ahead and place 5 pi over 4 into the appropriate quadrant. So in our case, 5 pi over 4, that's an improper fraction, so it's bigger than pi. That's less than 1.5 pi's, or 3 pi over 2. So it's going to fit into the third quadrant. So 5 pi over 4 wraps around this far, approximately. Next, I'm going to go ahead and find the reference angle is always drawn to the x-axis. I'm going to call that theta bar. And theta bar can be computed as 5 pi over 4 minus pi, or I'm going to rewrite that as 4 pi over 4, just kind of strategically rewriting this pi. So I have a common denominator, and our reference angle in this case is going to be pi over 4. All right, so I'd like to plug in this reference angle to where the 5 pi over 4 is. However, we want to be a little bit careful that this is equal to the cosine inverse of sine of pi over 4, plugging in that reference angle. But as soon as we plug in that reference angle, we want to be very careful about which quadrant we're located in. So we're going to be located in the third quadrant. And remember, all students take calculus. So in the third quadrant, only tangent is going to be positive. As we're trying to evaluate sine of 5 pi over 4, that overall is going to be a negative. So I need to include a negative out in front here as I plug in my reference angle, the pi over 4. All right, next to evaluate this, I'm going to go ahead and say, well, that's cosine inverse. Bring that part along. Let's evaluate what's on the inside. So the negative comes along. And then to evaluate sine of pi over 4, that's a nice angle that we see quite often, right? Equivalent to 45 degrees. But we can say sine of pi over 4 is going to equal the square root of 2 over 2. All right, the only thing that remains to be done in this situation is we need to evaluate what's cosine inverse of negative square root of 2 over 2. So this gets a little bit complicated, but when we're dealing with cosine inverse, if you have a negative on the inside there, we have to be very careful about what angles are output here. All right, that we need to, we're probably thinking, okay, well, cosine of pi over 4 is going to produce a square root of 2 over 2. However, based on all students take calculus, and what we know about inverse functions, we're going to need to be thinking, okay, that angle, that pi over 4, let's use that as a reference angle into the second quadrant because we have a negative going on here. I know that cosine is going to be negative in the second quadrant. So let's do the calculation. What's the angle that wraps around here into the second quadrant where cosine is going to be negative? That's going to have a reference angle of pi over 4. So again, to calculate this angle, what we're going to do is we're going to start with pi minus pi over 4. So pi minus pi over 4 is going to give us 3/4 of a pi remaining. And that's going to be the angle that we're looking for. All right, now why that happened was if I set this equal to some dummy variable, we're looking for when we get an angle, when is cosine of this angle going to equal a negative square root of 2 over 2? Just kind of rewriting this equation here. You can see that cosine applied to both sides of this equation. We're going to get cosine of x on the right-hand side is going to equal this inner ratio. And what we're looking for is some angle that when we plug it into cosine is going to produce a negative ratio. We can't use the fourth quadrant just based on how inverse cosine works. So we have to use the second quadrant and place this pi over 4 in the second quadrant as a reference angle and calculate this angle into the second quadrant. So our overall solution here on this one is going to be 3 pi over 4. A little bit complicated, but just take your time as you're going through these. Whenever we have an angle given to us that is outside of the first time around, between 0 and 2 pi, I tend to like to use coterminal angles and make that one that we're comfortable with by either adding or subtracting 2 pi till we get to an angle we're comfortable with. Plug that in, evaluate the inner function, and then work what we know about an equation like this, cosine inverse of a negative. Rewrite that in terms of cosine, and then use another reference angle in the appropriate quadrant. All right, hope this helps. Good luck on them. I know these can be challenging.